if it's actually working this time. YouTube. No way to enable chat right now. Need a second monitor, and I'm already streaming, by the way, just so you know.
Okay, thank you for letting me know.
Test. Wow, it is 30 seconds behind. Okay. Let's pause that. Okay, what's up everybody? It's George back at it. Different approach this time. I'm doing live streaming. I'm just learning this. So thank you Barnacles for showing me an easy way to do it. So let's just get straight into it. Let me grab something. Back. Okay. This is the proximity sensor. I have looked for one that'll work with an Arduino 5-volt source. I have found one. And if I could find a power supply right now, because I don't want to plug it into my laptop and screw something up, I'll be able to show you. But basically it does work. And what I want to do is take the Pro X frame, which is back there, which you probably won't be able to see, and so it's going to be for the Pro X and M201. This is the fan bracket that it comes with. Now once you build it, you'll see that depending on the type of head you have, this fan bracket's actually quite useless, and depending on the model that you're using. Pro X, it's probably useless versus say the M201, which would probably be more of the reason for this design. See, they use more than one design with the same frame. So for those of you out there who do not know, the M201 and the Pro X share the same frame, and that's the reason for the cutouts on the top. It's so you can put a Bowden type extruder. Now essentially I'm going to take this bracket, replace it with a printed bracket that will be held in place. So as you can see here online, or on my screen here, let's go to, I've already drawn out the part and I'm just gonna redo all my parts. So you won't see the measurements and I'll just talk about them as I go. Now first I had to come up with a general idea of how I wanted to do it, and then I thought, well, doing it this way is kind of hard, where I basically drew the circle, extruded up a shape, made the bullet shape, drew the circle, then made the bullet shape by adding a square and cleaning up the corners. And then I extruded out the shape, split the back in half. Then I came up with where the keyholes would be for the screw and for the where this keyhole is for this piece of acrylic that comes from the extruded bracket itself. So this is part I3B13. That's laser etched on there. So let's start getting into the design. So first I drew out a block because I knew it was going to be 8 millimeters thick. And then I extruded the shape up to, I believe it was about 40 millimeters. And this is 50 millimeters wide, by the way. So after I did that, and then drew the bottom line of where I want this bottom of the bracket to be extruded out, and then I pulled out the shape, after I drew the bottom shape, I drew the center lines of where the holes are going to be which is this hole right here. And originally I was going to design it so it sits on half of it, but due to stability reasons, I think it's just best to go with the full entire bracket and replace it. So from the center, I marked out where the holes would be. From there, I extruded the shape out to 40 or 50 millimeters. I think I went 60. I went a bit over because I knew I was going to clean up the distance afterwards. So from there, I raised the center lines that I had for the holes, which come on it. And SketchUp is pretty easy to use for you first timers. And Fusion 360 is like the next step up. However, when you start using Fusion 360, I don't think you ever want to go back, because a parametric timeline is awesome. The only thing I don't like about it is it is a cloud-based system, so you're depending on a signal to the internet all the time. So anyways, back at it. From there, I drew the center line of where the holes were going to be. And I just took a measurement, and you always want to base your measurements for each hole off the center of the hole, because when you draw your circle, it's based off the center. Now from there, I had to draw the thickness of this little plastic bracket here, so I'm ensured that it's going to be holding on, right? From there, I then drew out the bottom half of it so that I knew the complete dimension of where the bottom of the hole would end up and the top of the hole for this square key. After that, I deleted the center line, and I cleaned it up a little bit by adding in 2 more rectangular shapes on the left and the right. And you may see it as just 2 lines that got drawn out, but actually what I did is draw 2 rectangles and just punched in the measurements. As you're going, you'll notice that this line is actually 5 millimeters to the center here, 5 millimeters to the center here. I think this was dropped down 2.8 millimeters from the top. But since I'll share this model in Thingiverse, you can check out everything there. That'll be in the future though. So from there, I cleaned up all the other lines that I did not need, which were those lines, so I was left with the center square. I then drew out the circles, I believe, for the holes. And again, that's based off the center. Now, these are 3 millimeter holes for an M3 screw, and you want to go oversized by at least 1,000th, maybe 2,000ths, or excuse me, 1 or 2 microns is not enough. You need like 100 microns of clearance. So after that, I started cleaning up all the lines around the circles that I didn't need no more, that I just used for the primary alignment of it. From there, I believe I extruded out the holes, and we can change the angle so you can see one is actually clear. You can see that green line in the background from the x-axis. And then I extruded out the other circle, then the square, and as you can see, there are holes. There's the part in the background, and all I used was this simple shape tool right here. Works pretty good. I'll draw out another part because I'm just getting used to the streaming, so I wanted to make sure it's going to come out good before I did a real stream of something else. I'm using a $250 laptop from Walmart, so my capabilities aren't that good as far as what my resources are and what I can do with it. But I think I'm doing all right. Now, getting off on a little tangent here, so let's get back to what we were talking about. From there, I had to draw out the whole diameter of this part. Now, it was... I gotta get my micrometer. Now, this is standard Harbor Freight. I bought the 8-inch scale. The reason why I bought the 8-inch, not the 6-inch that was $20 cheaper on sale, this and that, they're the same quality, yes. However, my build plate is 200 millimeters by 200 millimeters by 180. So it only made sense to buy one that was at least able to measure the full capacity of my bed, since this is primarily for my 3D printer. Now, this comes out to 17.85, and that's up against threads, and that's millimeters. So what we're going to do is just make an 18 millimeter hole, which is what I did here. Now, all you have to do, if you're going to draw a circle, when you draw the circle, put your pointer, drag it, and it'll snap to a center line, like so. And you'll see that little blue dot. So when you start from a corner, then move in, then you have a center line. And if you wanted to go based off another center line along with it, go to the next one, you'll start seeing this red dot. And it's a little hard on this shape, so I should have picked a different one. So here we go. So we're going to look for this center line, drag up, it'll automatically snap to the center. Then we can drag out, and then try to find the center. And if you wanted to go, say, based off this circle, you could then find the center of the circle. If you drag back out to this line and then base it off this center, it'll actually draw like an L shape. But since I have the circle here, I keep interfering with the circle, so screw it. From there, I then drew an offset of what the washers Oh, you're kidding me. There we go. Drew the offset of the washers, which was, I think, 30 millimeters. 29.61. So yes, 30 millimeters. And they're fairly large, but just in case anybody wanted to use them, I figured why not just leave them on there. Originally I wanted to design it so that I could just use the nut and thread the actual print, but I know people have problems with just trying to put threading or just trying to print out an accurate print, so I'm trying to leave the tolerances within everybody's capabilities, and even for people who have not fine-tuned their skills yet. So from there I then drew the offset of 1 millimeter, 1.5 millimeters I think is what it was. So when this is sitting on there, and if it's got some play whatsoever, like it does here, which you're not going to be able to see, but this little bit of play will help you move it to one side or not have any interference whatsoever. That's better. Now, as I stated before, I wanted to move up the edge. And I drew this bigger than I needed, so we'll undo it and redo it so you can see what I pulled the wall out by 4 millimeters, and then I brought in the other side by 4 millimeters from the rear. So, and that was simply just using this push-pull tool right here. And that's what I also use to extrude out the hole parts and everything. From there, I wanted to get the same kind of bullet shape design, but not necessarily the bullet shape, because I didn't want to have to draw another circle over this curve. So I simply just took the pencil tool and drew 2 lines coming down to these points. From there, I took the push-pull tool and I pushed the surface downward, which once you go to the maximum point, it'll turn like this opaque gray kind of weird glitchy look to it, and then delete once you let go if it snaps to that line. Now you can always snap to any line whether you wanted. So for example, when I did these holes, I clicked on the actual hole itself and I snapped it to this line, which was the back of the model. Once it did that, it knew it's just a hole because you just deleted this part. So it kind of works that way. Now from there, I then pushed out the hole in the bottom, and then I started deleting my offset lines for the 1mm gap tolerance that I have for the washer. And from there I just cleaned up the other lines that I didn't need, deleted the model in the back. Now from there, I then selected this model and turned it into a group. And once I select, you'll see that now this part I cannot edit by itself. And just going to show you a few tools. Since I showed you this part, let's show you a little bit how SketchUp works. So say if I'm going to draw out a square, if I did 50, 50 and hit enter, and that with the way you do that is you just click and don't click again, you just drag. So click once and drag. If you have this diagonal line in it, that means you're perfectly square. 31mm by 31mm. You see the dimensions in the bottom right corner. The first one I think is the red axis. So let's do 50 by 20. That's right. Okay, so the first number is going to be your red axis, which it's just easier to call it a color because this is reference in color. And essentially it's the X, Y, and Z. So Y is green, I believe, and X is red. So the first number is a red X line, and the second number is Y, the green line. So if I were to click on this, now I can hit Control Z and delete my part, or I can hit Control Y and move forward. I can hit Control Z and start adjusting my part back to 0, as you see here. So this is how I did it. I essentially just drew the part and stepped it forward. Now, once you have the shape, say 50 by 50mm, and all my I'm drawing in millimeters in this model. Now we're going to do that circle as I was talking about. Now say if I wanted to put a circle in the very center, it'll snap to the center, midpoint. If I draw out to here, kind of disappear, look for the other center, midpoint, and draw out, and usually it'll meet up like that. So now I'm at the exact center point of this. And another way to do it is if you just draw a line diagonally from corner to corner. But since we have a computer to do it, we do it this way. Now, all my circles in SketchUp, they're not perfectly round. They're kind of blocky. They're a polygon shape. So low polygon instead of high polygon, let's just say that. Now, when I drag, I like to drag on one of the axes, whether it be green or the red. So Y or X. Now remember, when you draw a circle, you're drawing from the center to the outside, and that's the radius. So if I need a 40mm hole, I'm going to draw it out 20, and I'll have a 40mm hole. And I know that this is a 50mm square, and that I have 10 millimeters spacing in between here and here. So say now I wanted to draw out that 8 millimeter gap or thickness of this part, because I know that's what's going to come up, and it'll follow the same patterns and thickness of part as originally built on that machine, except this is going to be a 3D printed part. So I know that this was 50. Well, actually 50 is on the green, so we're going to punch in 8, 50. Wait a minute, did that wrong. I forget how the square works. So first number I think is your longest one, and then is your second. So this is 50 by 8, and maybe I drew a smaller circle, a smaller square. Oh, it's a 50 by 50. Off in my radial dimensions, whatever. Got to go back to math school, learn my math. Anyways, push-pull tool. So say if we wanted to pull this tool out 8 millimeters, oops, 8, punch in enter, and it's always just click and drag up. And let's say we wanted this one 20. So now say if we wanted to put that hole in the middle, and we're going to do it in the center of this. So we're going to go to endpoint, and it should snap to the center. From there I'm going to stay on the red axis. Whether it be red or green, either one doesn't matter, just stay on either one of those. But if you're on a black line, it's harder to line up the circles because they're rough polygons. And we'll do 9, so it'll be an 18 millimeter. Now I want to make this a hole, so we're going to use the push-pull tool. Now I can snap to this edge right here, which will snap it to there, and now this depth and this depth is the same. But say if I wanted to make it a hole, so I'll snap to the very bottom, and now let's pivot over. The other shape was not complete, so we'll undo it. We're now going to draw a little line on the bottom, since when you extrude from a flat surface, it doesn't always make a cube. So we're just going to close this up by simply drawing a line. Now that we've closed the hole, we can delete this. We can even delete this if we wanted to. And say we'll go back to the push-pull tool. I'm going to rotate around. And now I'll snap to the very bottom edge. Now it's a hole. Now I'm going to rotate this around. You'll see I now have this 18 millimeter hole, 40 millimeter bushing around it, but the bottom is like that. So just a little something in SketchUp that I wanted to show and try out this live streaming. This was not the best, not scripted, but I don't think I ever will be. So now I just want to delete this, or I can just hit Control Z. I'm left with this part, my component, which I made into a component by simply selecting all, right clicking, and then make into component. But that's not highlighted here. So from this point, we're going to show you how to, I'm going to show you how to convert it to an Stl file. Now, first, you always want to save it. And in my case, I've already saved it as my prox auto level bracket. So yes, replace it. Now we're going to select the model again. Select it. Once you have it selected, scroll down to Export STL. Now the first reason why, the first thing I saved was the actual DRW file, the drawing file of Google SketchUp that you can put on Thingiverse, and this way other people can mod it a lot easier. You know, if you're open source, why not share your design? If you want to sell it, then go patent it. So from here, we're going to export as STL. Then you want to select ASC2. And I have my model in millimeters, so I'll export it in millimeters. But here you can actually convert it for your printer, the way it's set up. In my case, it's all millimeters. So I'll export it, and then I'll select it to an STL file, which, as you can see, I already probably have this. So let's see my STL files. And we'll look up by name. There it is. So I saved it at 9:38 a.m. yesterday. So I'm not going to save it again, just whatever. So once I have it saved there, and we'll go over to Repetier host. This will take a second, so hold on. I'm going to close out Google SketchUp meanwhile. While that's loading, thank you very much to the person printed these out for me. You know who you are. I call him Repo Man, otherwise known as. And he did some stickers for me with the printer in the background, the boards in the background, different colors, awesome vinyl. This guy, we'll put a link to his store eventually in the link, but he does consoles. He did this as a favor to me because of all the help that I gave him with this 3D printer. Did some of these, and even did some of the small ones, which I don't know where they're at right now. They're probably over there somewhere. So now that I have Repetier host open, we want to load a part, and I'm going to tell you real quick. When you load a part right here versus load, you can only select one STL file at a time. Now I like selecting from here. Add object under object placement tab. Once you do that, you can select one. If you hold down shift or control will let you select different ones, while shift will allow you to select a group of things starting from the one point that you started at. So in this case, we're just going to open up my proximity bracket, which I glued to the horizontal plane. Now Repetier host should automatically center it. And I need to switch my printer over 2 inches or millimeters, because I had switched it for another person. So I'm going to delete this. I'm going to add the same object. Now that I have it selected, and this is also to show people how Repetier host works. So now that I have my part selected, one quick thing that'll show you right here, it'll tell you if your mesh is good or not. And sometimes it can print with the bad mesh depending on how bad the mesh is. And the other one is a collision alarm. So this will automatically center your part and drop it on the build plate. This will just drop your object down to the build plate. If it's, say, floating in space like this, this will just drop it down. Oh, let's move it to where it's over here somewhere. Let me change the view. How about that? change the Z by 10. So now you can see it's floating in the air. I'm going to select my object and I'll just drop it to the build plate. Let it catch up here. So now that it's dropped to the build plate, I can rotate the object. Now, one thing about Repetier host that I kind of don't like is that this little center cross is your pivot point for your camera. So let's just center the object. I'm going to go to the front view. I'll then move to the move viewpoint, and I'll move this cross down to where I get it to about the center of the bed. From there, I can then rotate how I want it. Zoom in, and then I can double check how my part is oriented, making sure it's correct the way I want it. In this case, I don't actually like it when it's way over there. I just bring it closer to the edge, and since I want to make sure it's on the build plate, I'll hit drop object and let it drop the object. And then we can move this viewpoint over to that very simply, and we can rotate. Well, it's always easier to do it on the front view and then move the viewpoint. I don't know why that is, but it is. I don't want to deal with this right now. You have to do a top view, move the viewpoint, and a front view, move the viewpoint. So I guess I will. There we go. So rather than not describe it and just let you see what I did, all right? That was easier. Raw, unedited footage. So now that I have the part there where I wanted, we're going to go over to Slicer tab. When you click on Slicer tab, in the old version of Repetier host, and mine is actually the G-Tech version of Repetier host, you can pay Repetier host to make a version with your name and your printer specifications programmed into it if you pay a sum to them. Same thing with Cura. Now, if one wanted to change some settings in Slicer right now, you could. You could just click configure and it'll take a minute. Slicer will then pop up. If you know your settings already, we can simply hit it here and select the print settings, your printer settings, your extruder, and then hit slice. Now I'm going to wait for Slicer to pop up. Come on. Well, maybe I'll do some other stuff meanwhile. So now these configurations I've shared on my WordPress blog, and you can check it out at georgeroblesjr.wordpress.com. If you go to my latest blog with the pictures of my Z-axis indicators and filament sensor, then right there you will get the firmware plus my entire set of printer settings or slicer settings that I'm experimenting, playing with. Some I just kind of pushed off to the side. And I never update this slicer. I do have a newer version of Slicer with the 3D plater on it, but I like this one for simplicity. So as you can see, I have quite a few on here. So we're just going to go ahead and go with speed test 1. Actually, I'll go with speed test 3. 0.2. Now, as you can see, my title doesn't fit. So what I do to read the title, I'll hit save. So I can read the entire thing. And then just click OK or what, click cancel, it doesn't matter. So here are my layer height, perimeters, and I'm going to talk a little bit about this in a different series later on, where I'm going to explain slicer settings for the everyday person, so you can understand it, so anybody can understand it and use it. It's more of a technical based deal, so if you're more of a technician, you'll like Slicer better. If you're more of a visual based, you might like Cura better. Scheme forwards I never use, which is down here at the bottom in this version, Repetier host, but I think in the newer version they took it out. So I'm not going to go through all that. My filament settings, I have so many different settings, including one for my filament sensor, which I have set to just 3.0, and I'll scroll down to that. Now, you can see here it's 3 millimeters. Even though I run 1.75 millimeter filament, I do not need to change anything. I tell it the nozzle size. I tell it what filament is the size is supposed to be, which is 3 in this case, so I can fit in either 3 or 1.75. I then just feed in the filament. It'll compensate and ramp it up by 200, 300% and kind of go with it. Now the accuracy isn't as good. I admit to that. If you're good at it, then fine tune it, adjust the filament size to your filament size. However, I set it up this way so right off the bat, anybody with 3 millimeter or 1.75 millimeter filament can just start it. So if you import my filament, my slicer settings, which is this is how you do it. So first you want to go to File, then Preferences, and then make sure you're in Expert mode. Once you're in Expert mode, actually in Expert mode, you're allowed to shut off the updates, which I'm not going to check for updates anymore. I need to get going though, so we're going to try to hurry this up a little bit. So I'm going to go down to my 1.74, and the reason why I have so many diameters is because I took an average measurement of one roll and it came out to like 1.73. Then I just figured, well, if I'm going to base it off that number, why not just do 173, 172, 174, 5, 6. So I have a couple different ones. As I come across them, I'll add them. In some cases I just copied it and saved it as a different title and changed the numbers here. Now for ABS, I use a 0.95 extrusion multiplier. For PLA, and you can see my temps there. So for PLA, I run a 1.0, and your mileage may vary. It just depends on your filament. I use the cheap Chinese stuff. Now my printer settings, you're going to want to make sure that's good. My custom G code is a little bit complicated for my auto leveling, and filament sensor. So I'll just show you my auto leveling, and there's a couple different things that I have added that is designed for a deployment bracket that I'm designing. It's disabled for anyone who downloads it. Right off the bat, as you can see here, I have the semicolon in front, which disables that line. If you wanted to enable it, then you would hit it. And I got some things that I describe exactly what I'm doing. So you can scroll through all of this, and each one is described, but I'm mainly using the ones that are here for retracting my probe in these movements. And I have a magnetic retractable probe, but you have to manually deploy it. And I'm working on a deployment bracket using G code. So that's Slicer in a nutshell. Not a very good one. Like I said, I'll do a better series on that, and I'm going to do separate series on each section. So in here, I have all my filament settings set up the way I want it to. So on here, you need to select what you want. We went with speed test, I think it was 3. PLA 1.74, I'm on my auto level bracket. Now I just hit slice with slicer. Now about this Repetier host is it allows you to move your object on the plater in 3D, and this works in conjunction with Slicer. Slicer now has its own 3D plater, but it has a couple little quirks that need some work. So for example, I have this cube shape, which is the maximum build volume that my printer can reach, or the nozzle can reach. It's easier to move an object in here, rotate around it, having a separate program doing the 3D modeling, and then another program just doing the slicing. And this is my free way of doing it. So, under G-code editor, one can add different things to the start, end, run on kill, run on pause, everything like that. So Cody, I would recommend you adding stuff on run on pause for the way you want to retract and change filament, then to just program it manually. This way it's in a script that you can always call up. I don't remember off the top of my head how to call up the script. There's instructions right here for anybody who wants to know. There's a download, there's a Repetier host manual that you can download. Now, I have the G-code already generated, and one can see right here, I put in a semicolon under every layer that's changed. And the reason why is because if I ever do a temperature torture test, or if I just wanted to change a color on a specific layer, this separates the layer for me. By adding a whole bunch of semicolons, I put like 20 in there or something, and then I added an M25 at the end so I remember what it's for. So I'm going to scroll down a little bit. And so I was like line 35. That started the first layer, I think. Now we're going to try to find the second layer. As you can see, I'm already in 300 lines of code that I've passed of G-code. And the reason why why there's so many is because when you're drawing a circle or a curve shape, you need to specify a point, then the next point, then the next point, then the next point, next point, next point, a circle. And if you punch in the numbers in the same row, you're going to move in diagonal position. Or if all the axis movement is done in one row, then all three will move at the same time. In this case, which is X, Y, and the extruder. The Z comes up after, just before a layer change. As you can see here, G1, F9000, which is the feed rate, E25, which is the extruder, and then it goes to E0 to set that layer. So it's like resetting everything to 0 for the next layer on as far as how many steps it used to move forward. Excuse me. G1, Z0, 0.350 is now moving my Z-axis nozzle up to 0.35 millimeters from the build plate. And since I have auto leveling enabled, my auto grid leveling, I touch off on 9 different points on the bed. The Z-axis will constantly adjust itself, making the nozzle closer, further away from the bed, ensuring that it's that constant 0.1 millimeter gap distance between the glass or the layer before it to the nozzle. Now, and that's just the first layers, because depending on what your nozzle size is, if you have a 0.4 millimeter and you move it up 0.3 millimeters for every layer, then obviously that number is going to change. So we'll not get into that. So as you can see here, that was just for that first layer was essentially 665 lines of code for one layer. And that's to draw the little skirt around it, move in, and then draw out the part underneath it in a solid layer, and then move in a zigzag fashion, filling it in. if I wanted to see what this layer is doing, I can click on Show Single Layer or Show Layer Range, depending on which one you select. Now, Show Layer Range will show you the part being built up from the bottom up. Show Single Layer will just show you every single layer. So for now, we'll just do a single layer. We'll zoom in to where I was. And then on the first layer, you can just hit up. And then you can start seeing each of the different layers. Now I'm running a 40% honeycomb. So this isn't exactly fast, but it's actually my high-speed, high-strength test. Rectilinear, the plastic is only supporting on the points that it crosses. This honeycomb shape has a complete supported surface across the entire layer. That's the way I like it. And I also have it so that it extrudes a little bit more at the edges to ensure that there's a strong bond at the edge. As you can see here, I have 3 shells. My extruded width with my 0.3 millimeter nozzle is 0.42 millimeters. And that is for the width of the plastic as it gets extruded out the nozzle and then is squished flat by my nozzle. And so it should be drawing 0.42 millimeter lines out there for anybody using these settings. If you adjust the nozzle size, you're also going to want to adjust the extruded filament width size. Because if you change it to 0.4 nozzle and your extruded width is 0.42, it's not going to extrude it very well. You might want to bump it up to 0.52. So as I go through these different layers, and I'm down to like 3 minutes here before I need to go, you can see each layer. This is how it does the honeycomb shape. So it does this little zigzag, and it kind of sounds like a machine gun as it's going. Now we're going to go to Show Layer Range. So this, go to the max. Oops. Set that to 0. Set that to 0. Now you go to the last layer on this one, the Show Single Layer I was showing you on the first layer, and adjust both. Now, as you can see here, now I can see my part physically grow. And showing you every single layer, every movement that it does, building up. Now, I don't have supports enabled, so you will not see supports for the holes as it's extruding upward, and this is nice for that little bit of preview. Now supposedly if you go to manual control and set it to dry run, you should be able to run this without the extruder. I have not had luck actually enabling that. So there's the bottom of the cube with the cutout, and it'll keep getting extruded, and then it'll do the multiple layers for the holes, and then the part will be done once it completes the top. There's the bridging, and part is complete. Now what I'll do is one of 2 things. You can run the job if you're connected to your printer, or you can do what I like to do, which is save it to an SD card. So now that I have it on SD card, here, and prox auto level, and bracket pro x and 2 1. I'll put a lot in the title. So now that I'll save that, and I'll include the start end commands, finish, and that's what that's talking about is over here in this G code, what you put in the start and end codes. So now that I have that, I have it on my SD card. Now eject my SD card and start printing. Meanwhile, I need to go to the doctor's appointment right now. And I gotta get ready. Everybody have a wonderful day. God bless. Thank you for enjoying me on this live stream, even though nobody was there. A lot of people probably watch it afterwards. So again, this is just me trying it out. Maybe I'll do a Twitter account. Ugh. Yeah, I'll make a Twitter account and probably do this for work. I have actually started a Facebook. Oh no. I hate Facebook with a passion. I did it just to put my company's name out there more with my friends to see what they're doing. And it's kind of cool, you're connecting with them and all, but just, I don't want to go through everybody's posts. you kind of get like lost in it. But anyway, this is a little rant on Facebook. God bless, and y'all have a good one. So stop streaming.